Hello. So today I'm going to introduce you to the differential calculus. So in general, if you talk about what is calculus, so calculus is basically a branch of mathematics, all right, which was built basically on algebra, analytical geometry, and trigonometry. Okay, so it's basically a branch of mathematics. That is what is calculus. Calculus. Okay. Now in calculus, what do we do? Okay, that is the basic question. So the answer is that in calculus we basically try to analyze and model the changes. Model the changes in any quantity, in any structure. For example, velocity, time, slope, right? All those things, many applications are there. Okay, and all of you know that change is a part of life. So if you see a change there, we can apply a calculus. We can model that particular change and we can solve the problem by doing proper analysis. So that's the whole purpose of calculus. All right. Now calculus has been divided into two parts. It has got two branches. All right. One is the differential calculus, and the other one is the integral calculus. Okay, we are going to learn about both of them. Today, we are going to start with the differential calculus. As the topic, as you can see, is that. Now, before I move there, let me tell you one thing that integral calculus and differential calculus, both of them are basically have the same foundation. Okay, the foundation is the fundamental theorem, is the fundamental theorem of calculus. Okay, so this fundamental theorem of calculus basically binds the differential calculus and integral calculus. Well, enough. Let's talk about some application. Okay. So suppose all of you know how to, yeah, not suppose, all of you already know how to, ride a cycle, right? A bicycle. So suppose there is a path like this, a straight path. Okay. Then there is a steep hill, all right, going down there. Again, there is a straight path like this. Okay. So it's your path on which you are going to ride your bicycle. All right. Now let us divide the whole part into different parts. So from here to here, suppose it is AB, it is the first part of your ride. B to C is your second part. Okay, it is your second part. Your third part is going to be C to D, and from D to E will be your fourth part. This is going to be your fourth part, which is from D to E. So you are going to start your journey from A point and you will be going till E point. All right. Suppose you are here right now. Okay, please excuse my drawing. This is your weird bicycle. All right. This is the seat and everything. Okay, and you are here. All right. Standing. Or not standing, you're riding the bicycle. Let me extend your feet. All right. So in the first part of the journey, as you can see, you are going to travel almost the same distance in same amount of time, right? So your velocity, or I can say your speed, is going to be constant or uniform, right? Now in the second part of the journey from B to C, what will happen? Your speed or your velocity is going to decrease. Obviously you'll be going up, it will decrease. Then in the third part, what will happen? Your speed is going to increase. You will travel more distance in less time. And in the last part of the journey from D to E, you will have again almost the uniform or constant speed, right? And if I try to draw the diagram or the distance time graph for this particular situation, it will look something like this. Okay, this is the time, this is going to be your distance, this is the distance on the y-axis. Very basic graph, you already know about this. Okay, so you'll be going like this. Okay, in the first part of the journey. In the second part, you will travel less distances, more time, right? It will be something like this. I'm drawing straight lines for now. Then in the third part of the journey, what will happen? You will travel more distance because your speed is going to increase, right? In less time. So it will be something like this, steeper. Third part of the journey. And fourth part of the journey, it will be almost like the first one. Like this. This is the fourth part. Okay. Now you know how to calculate the average speed here, right? You know how to calculate the average speed here. Now if I ask you what will be the speed, what will be the speed at this particular point, suppose this point is P. At this particular point, at the particular time, what will be your speed? Can you accurately tell that? Or randomly, if I pick any point here, suppose this point Q, what will be your speed at this particular point? So that is called instantaneous speed, right? Instantaneous speed or velocity, that you are trying to calculate the speed at that particular point of time, right? So that is something we were not able to achieve using our algebra. So we need to have this particular branch of mathematics which can help us calculate the instantaneous speed of a particular object. It's one example. There are infinite number of such applications. Okay, let me show you here. As you can see, this is the distance time graph for some other motion. Okay, and clearly, in general, when you are calculating the speed here or velocity here, you were calculating the average velocity from this point, suppose A point to B point, right? You had this time from 4 to 10, that means the bracket was 6, so 10 minus 4. Then what was the speed? Difference between the distance, 4.25 minus 2. So total distance traveled divided by total time taken, the normal velocity, right? Average velocity formula. But the question was, at this particular point, suppose P point, what was your speed? So that is called instantaneous velocity. That at 7 seconds, what is your speed? So that is not possible using this formula. That's not possible. So comes the concept of calculus. Okay. Now let us move further. So in calculus, students, the first step of studying calculus is to learn the concept of limit. Okay. Now what are limits? Let's understand the concept of limits through this particular example. So I have a function here, f of x, which is equals to x squared. Okay, it's a simple function, quadratic function. Now I have got two tables here also. This is the first table and this is the second table. Okay. Now what is happening in the first table is that I have taken the value of x as 1. So f of 1 came as 1 square. So I got 1. So f of 1 is going to be equals to 1. Then what I did is I am increasing the value of x from 1 to 1.9. So what will happen in that case? F of 1.9 will be equals to 1.9 squared, and that will be equals to 3.61. So f of x became 3.61. In the next step, what I did, again I increased the value of x to 1.99. So the result is this. Again I am increasing the value of x, result is this. And again increasing this. But look at the values of x which I have taken. I have taken the value of x starting from 1. Then I took 1.9, then 1.99, then 1.999, and so on. So what I am doing? I am trying to basically reach 2. Okay, I am trying to reach 2 as the value of x. right? So I am going from the left side on the number line. If you see the number line, right, let me draw it for you. If you look at the number line, this is the number line. Okay, so what is happening on the number line here is basically I'm trying to go to 2, right? I'm moving from the left hand side, right, left hand side, and trying to reach 2 for the value of x, right? In the second table, if you look, I started with 3 from 3, right? Then I got f of 3 as 9. Then I went to 2.1. I got f of 2.1 as 4.41. Then I'm decreasing. So suppose this is 3. Now I'm decreasing the value here, right? I'm decreasing the value here further and further so that I should reach 2. So from the right, I am again moving to the left, right? So from the right hand side, I am going to 2. Right hand side, I am trying to reach 2 for the value of x I am talking about. Okay. So in both the cases, I have not reached 2, right? I have not taken the value of x as 2, but I am trying to reach 2, right? In the first case, I am trying to reach from the left hand side. From the right hand side, I am also, in the second case, I am trying to reach from the right hand side to 2. But I am not going to 2 exactly. Okay. So this is nothing but the concept of limit. Okay. Let me show you how we can write it. I will write limit LIM. This is how I write it, or we write it. LIM, limit of f of x. Okay, I am talking about the left hand side. What is happening? Limit of f of x when x, I will be writing x here below limit. Okay, LIM. X is reaching to, x is reaching to from the left. To signify left, I am going to place a negative sign like this as a power. It's not a power, it's just a notation. Okay, it is telling us that I am calculating the limit of f of x when x is tending to 2 from the left hand side. Okay, in the same way for the right hand side also I can write limit of f of x. I am calculating the limit of f of x such that x is reaching to 2 from the right hand side. Can you guess how to represent that? Correct, plus. So I am reaching from the right hand side, I am reaching from the left hand side. Now what is happening here? What is happening? If I am reaching from the left hand side, this is the value I have got till now. And when I am going from the right hand side, I am reaching here somewhat. Right? If you look at these two values, where am I reaching? I am reaching to 4. Right? From the left hand side also it is going to go like this, 3.9999 and so on. And from the left hand side it will be like 4.00000 and so on. So ultimately you will be reaching 4, right? So from the left hand side also you are reaching 4, on the right hand side also you are reaching 4. And if this happens, that from the left hand side also you are reaching the same point, and from the right hand side also you are reaching the same point on the graph of f of x, then you can say the limit exists, and you can write directly limit of f of x when x tends to 2 is equal to 4 in this case. Got it? So what is the whole picture here? What is the whole picture? The whole picture is, or in simple word if I tell you, limit means where is the function reaching when the value of x is reaching somewhere. right? What is the behavior of that function when x is at this particular point, right? From the left hand side also and from the right hand side also. So let's talk about the definition of function, the informal definition of a function, sorry, of a limit. And it is that if f of x can be made as close as we like to some real number a by making x sufficiently close but not equal to a, then we say that f of x has a limit of a as x approaches a small a. Okay, and we can write it like this. Okay, so what does it mean? It basically means, let me tell you, that suppose you have a graph like this. Okay, let me explain you in a simple word. X, negative x, y. So y here is basically f of x, right? F of x. Or let me explain you here. Suppose there is a graph which is going like this. Okay, this is the graph of f of x equals to x square. Okay, now what is happening when x was reaching 2? Suppose here we have 2, okay, and here we have 4. So this point, let me make it more proper, let this be 2, this is 2 and this is 4. So this point is 2 4, right? So what is happening is you are moving, if you are taking the left hand limit, okay, which we had talked about, that limit of f of x when x is reaching 2 from the left hand side. Okay, so you are going from the left hand side, meaning in this direction you are going on the graph. Okay, so you're moving like this. Okay, you're at this point, suppose you are at 0, so you're moving like this, on and on and on and on. And just before 2, before you reaching 2 here on x, what is happening, which value you are reaching on y? You are reaching 4 on y from the left hand side. So this is called the left hand limit. So you are reaching 4, right? In the same way, if you want to go from the right hand side, what is happening? You will be going like this on the right hand side, right? Right, from 3 to 2. So you will move like this on the graph, like this, in this direction. So you're moving like this, and where you are reaching? Again at 4. You're reaching at 4. So this will be limit of f of x from the right hand side, that is equals to 4. So from left also you are reaching the same point. From the right also you are reaching the same point on the graph of f of x. So this value, which is 4, is the limit of f of x or the function. Okay, it is the limit of this function at that particular point, and you will write it like this, that limit of f of x at as x approaches 2 is equals to 4. Okay, let me repeat again one more time. Limit of a function is a value of a function, okay, when x is approaching at a particular point. Like in this case, the value of function x square is 4 when x is reaching almost equal to 2 from left hand side also and from right hand side also. So that's the informal definition of a limit. Now let's talk about this particular example, and then we'll wrap up. So this is a function f of x. Okay, now see one more thing. In the previous example, what was happening, that if you take the value of f of x as 2 at 2, what will happen? You will get 2 square, that is equals to 4. So coincidentally what is happening is that the value of the function, the exact value of the function at 2 is also 4. Okay, but this will not be the case always. Let's see. So this is the function And what we are doing here is we are taking the value of x approaching 0. It will not be equal to 0. See what will happen when x becomes 0. So if you put x is equals to 0, let's see what happens to the function. F of 0 equals to f of, instead of x we will substitute 0, obviously, 0 square divided by 0. 5 into 0 is 0, 0 square is 0. So what are you getting? 0 over 0. And this 0 over 0 does not have any value. It is not defined. Not defined. Right? So as x equals to 0, at x equals to 0, the function does not have any value. It is not defined. The function is not defined at that point. But still we can calculate the limit of that point. At that point, we can calculate the limit at 0 also. That is the whole thing. So if I break down the function is basically f of x is equals to fx plus x square upon x when x is not equals to 0. And when x is equals to 0, what will happen? It is not defined. So this is our function, that at x equals to 0 it is not defined. You can clearly see you are getting 0 by 0, it's not defined, but at other points it is defined. Okay, but still we are able to calculate the limit. How? Let me show you. Limit. Okay, so here comes, so that's the whole thing. See, from the graph you won't be able to find the limit always. So that is why we need analytical methods. So limit of f of x as x tends to 0 or approaches 0. Okay, so that will be equal to, so if you look at this from the left hand side, what is happening? As you can see from the left hand side, if you go, what is happening? You are reaching 5, almost 5. Okay, from the right hand side also, if you go till 0, okay, from left hand side you are going, you are reaching 0. As you can see from right hand side, if you are going to x equals to 0, the value of f of x is also reaching 5. So from both the ends, from left hand side, from right hand side, you are reaching 5. But at x equals to 0, the function does not have any value. It is not defined. Okay, so how to calculate then the limit of this function? Well, we can algebraically manipulate it. How we can manipulate it? We can take, let me just remove this thing first. So this is f of x, right, when x is not equals to 0. Now what I can do here is I can take x as common. So if I take x as common, 5 plus x over x. Now you know x is not equals to 0. When we are writing the function as this, x is not equals to 0. 0 and 0 cannot be cancelled out. It can't happen. But when they are non-zero, they can be cancelled out. So here x and x can be cancelled out. Okay, because they are not 0. Right? They are not 0. So we have got 5 plus x. Now if you calculate the limit here, limit of f of x when x is approaching 0, you can directly substitute the value 5 plus 0, that will be equals to 5. So the limit of this function at x equals to or approaching 0 is 5. Let me again repeat, the limit of f of x when x approaches 0 is 5. But the function is not defined at x equals to 0. It's a circle here. Function has got no value at x equals to 0. So that is the beauty of limit, which is the first starting point of calculus. Okay, so I hope you understood the introduction to differential calculus. So in the next classes we'll be talking about the rules, how we can apply the different rules to calculate the limits of a function at different points. Then we'll be moving further on, and learning about the differentiation as well. Okay, and the application, of course. So thank you.